In this lecture, we are going to solve some problems related to trigonometry. So the theory part we have already covered in our previous lectures. So in this lecture, I am going to solve five problems related to trigonometry from what we have studied so far. So let's quickly start. Our first problem is this one. So we are given sin x and cos y, and we are also told that x and y lie in the second quadrant. So remember, we had divided the plane into four quadrants. This was the first, this was second, this was third, and fourth. And we take this towards positive x-axis. This has 0 degree, this has pi by 2 radians. This is pi or 180 degrees, and this is 3 pi by 2. And we had also seen that in first quadrant all the trigonometric functions have positive values between 0 to pi by 2. In the second, sine has positive, so cosec will also have positive since it's 1 by sine x, and tan and cos are negative in the second quadrant. In the third, we have tan and cot, these are positive, but sine and cos and cosec and sec, these are negative. In fourth, cos is positive, cos or sec, others are negative. So we will use this property in this question. So we have to find sin x plus y. So we can write expand sin x plus y. We know that sin x plus y is sin x cos y plus cos x sin y. Now we are given sin x, we are given cos y, but we are not given cos x and sin y. So probably first we should calculate these missing values, that is cos x. So we know that sin square x plus cos square x is 1. So cos x will be 1 minus sin square x under root. And sin x is 3 by 5. So 1 minus 9 by 25 under root. 3 by 5 square is 9 by 25. And then 25 minus 9 is 16. 16 divided by 25, which is plus minus 4 by 5. But we are told x and y lie in second quadrant here. So the values we have to see in this quadrant. So here sine is positive, cos is negative. So this cos has to be negative. So we will pick, so you have to write, since x belongs to second quadrant, we will pick the negative value of cos x. So so I'm omitting that step, but you need to write that, because plus minus 4 by 5 is not equal to minus 4 by 5. You have to write that comment. Since it belongs to second quadrant, we will pick the negative value of cos x. Now we need sin y. So similarly sin y will be 1 minus cos square y 12 by 13. Square of negative is positive. So 144 square of 12 and 169 square of 13. So 169 minus 144 goes in the numerator. So it's 25, and denominator we have 169 is equal to plus minus 5 upon 13. So now in second quadrant sine is positive, so we will pick positive value of sine y. In cos we had picked negative value, but in sine we will pick positive value in second quadrant. So again we will write that comment. We have to write the reasoning before picking that. So now we have all the values required for this calculation. So first we can calculate these values, then write this line that sin x plus y is this. So this sin x plus y, now we have to just substitute the values. We have all the values. Sin x is 3 by 5, cos y is minus 12 by 13, next term is cos x sin y. So cos x is minus 4 upon 5, and sin y. Sin y is 5 upon 13. So this is minus 36 divided by 65, and again this is minus 20 divided by 65. So we can take 65 common in the denominator, and it's minus 36 plus minus 36 minus 20. So this will be equal to minus 56 divided by 65. And we just to make sure that this value is correct, one quick check, we can see that 56 by 65, its magnitude is less than 1, and we know that sine cos always takes values from minus 1 to plus 1. So this value lies between that range. So this quickly we can check, and it's negative. Sine is negative. So can x plus y, so sine is positive in first and second quadrant. So can this value be, what will be x plus y? X and y both lie in this quadrant. So both, the value of both of these are more than pi by 2. So even if these are slightly bigger than pi by 2, that is maybe 91 degrees, then also it will be more than 180 degrees. So it will either, if it's close to this 180, then it will lie in fourth quadrant. If it's close to this uh, first half of this second quadrant, then it will lie in the third quadrant or fourth quadrant. If it's close to 90, then it will lie in the third quadrant. So it will either lie in the third quadrant or fourth quadrant. It can never lie in the second quadrant. So in the third and fourth both quadrants, sine is negative. So this x, so, and we are getting a negative value which is greater than minus 1 and less than 0. So these two quick checks we can see. So suppose we had got here like 75 by 65, then we clearly know that this is wrong because its magnitude can never be more than 1. So this is our answer. I was just giving some tips for quickly verifying if your answer is correct. So now let's move on to our second question for today. So tan pi by 8. So this is equal to pi by 4 is 45 degrees. Pi by 8 is 22.5 degrees. But we only remember the standard values, not every angle. So we need to find out tan pi by 8. So we know that tan 2x, because if we know, here we know tan pi by 4 we know. So using this knowledge we have to find tan pi by 8. So from pi by 4 we need pi by 8, the value for pi by 8. So if this is x, this is pi by 4 is 2x, and we know that tan 2x is 2 tan x divided by 1 minus tan square x. This we know. So if x is equal to pi by 8, then 2x will be pi by 4. So we can put this value of x in this equation. This is the formula we have to use. So we get 2x will be pi by 4, and tan pi by 4 we know is equal to 1, and here we will put x. X is pi by 8. Divided by 1 minus tan square pi by 8. Or tan pi by 4 is 1. So we don't have much space here. So we can write this equal to 1, the value of this, or in next step you can write 1, left hand side will be 1 because tan pi by 4 is equal to 2 tan 8 pi by 8x, 2 tan pi by 8 there is no change to right hand side, 1 minus tan square pi by 8. So we can do cross multiplication. So 1 minus tan square pi by 8 is equal to 2 tan pi by 8. So this now becomes a quadratic equation. Our next step we can write tan pi by 8 whole square. So I'm just writing tan square pi by 8 as tan pi by 8 square. So it's same thing. And taking this to right. So tan square pi by 8 plus, I'm writing it in proper quadratic equation form. And 1 will be negative. This is equal to 0. So now this is if x square plus 2x minus 1 is equal to 0. So now we can use the solutions of quadratic equation to find tan pi by 8. So again, this is a quadratic equation. It will have two solutions, but we will pick one depending on the value of theta. So here this 2 is equal to b. So we know the standard form of quadratic equation is ax square plus bx plus c is equal to 0. So here a is 1, b is 2 and c is minus 1, and the solution of this x is given by x is equal to minus b plus minus under root b square minus 4ac divided by 2a. So here b is plus 2, c is minus 1, a is plus 1. So we can get tan pi by 8 as minus 2 plus minus b square is 4 and minus 4ac becomes plus 4, minus 4 times 1 times minus 1, and 2a becomes 2 times 1, 2. So we get minus 2 plus minus square root of 8 is 2 root 2 divided by 2. So we can cancel 2 from numerator and denominator. It becomes minus 1 plus minus root 2. Now pi by 8, where does pi by 8 lie, in which quadrant? So this is pi by 2, this is 0, this will be pi by 4, and this value will be pi by 8. So it lies in first quadrant, and we know that in first quadrant all trigonometric the value of all trigonometric functions are positive. So tan pi by 8 has to be positive. So if we pick this negative sign, this becomes minus 1 minus root 2, which will be negative. So we will pick positive value. So again here you have to write one line explaining that since pi by 8 lies in first quadrant, we will pick plus root 2 by plus root 2 minus 1. So root 2 is 1.414, so it's more than 1. So root 2 minus 1 will be positive. So this is our answer. Now let's move on to next question. So we have to prove that this left hand side term is equal to 0. So we can remember the formula of cos x plus cos y. We know that cos x plus cos y is two times cos x plus y divided by 2 times cos x minus y by 2. So that's why it's very important to practice and practice, then automatically you will remember these formula. So we can, using this formula, we can combine these last two terms. So we will write our left hand side is equal to, and don't try to skip steps while solving if you want to get the full marks. So here I may be skipping some lines. So left hand side becomes this 2 cos pi by 13 cos 9 pi by 13 and the last two terms becomes 2 times x plus y divided by 2. So 3 pi plus 5 pi divided by 2 is 8 pi. So 8 pi divided by 13 divided by 2 also, so it will be 4 pi only. 8 pi by 13 divided by 2. So 4 pi by 13 and x minus y is 3 minus 5 2 minus 2 divided by 2 is minus 1 and cos minus x is same as cos x. So it will be pi by 13. Now we see that pi by 13 is in both other terms. So we have reduced it from three terms to two terms, and 2 cos pi by 13 is common. So let's take it common and we will see what we get. So we are left with cos 9 pi by 13 plus cos 4 pi by 13. Now again we can combine these two terms using our same formula. So 2 times cos pi by 13 and this becomes 2 times cos 9 plus 4 13 by 2. So 13 pi by 13 divided by 2 becomes pi by 2. And second is x minus y by 2. 9 minus 4 is 5 and 2 comes in the denominator, so it becomes 13 times 2 26. But we know that cos pi by 2 is 0, cos 90 degrees 0, so this complete term becomes 0, which is equal to our right hand side. So this way we have proved it. Now let's move on to our fourth question. So we have to prove that the left hand side is equal to right hand side. So our left hand side, so we can expand these square terms. So first becomes cos square x plus cos square y plus 2 cos x cos y and second term we expand becomes sin square x plus sin square y minus 2 sin x sin y. So we will write this cos square x plus sin square x as 1 plus, and this cos square y plus sin square y, again it will be equal to 1. And what other terms we are having? Two more terms. So we have this term and this term. So we will write these together. Cos x cos y minus sin x sin y. And cos x cos y minus sin x sin y is equal to cos x plus y. So this becomes 2 plus 2, and this entire term inside the braces becomes cos x plus y. So this term becomes 2 plus 2 cos x plus y. But here we are having x plus y, the angle is x plus y, and here we are given x plus y by 2. So if this is theta by 2. So we know that cos, so we will use this formula. So we have to convert cos theta into, in terms of cos theta by 2. So we know the formula of cos 2 theta is equal to cos square theta minus sin square theta, or 2 cos square theta minus 1. So we can write this as 2 plus 2 times 2 cos square x plus y by 2 minus 1. So it becomes 2 plus 4 cos square x plus y by 2, and this 2 times minus 1 becomes minus 2. This minus 2 and plus 2 cancels, and we are left with 4 cos square x plus y by 2, which is equal to our right hand side. So we have proved it. Now our last question for today is, so here we have, again we see that clearly we have to combine these terms. We have to use the formula for sin x plus sin y and cos x plus cos y. So using these two formula we can write our left hand side. So this sin 7x plus sin 5x becomes 2 times sin 7 plus 5 by 2, which is 12 by 2 is 6x, So we see that already we are getting in terms of 6x, and in the right hand side we have 6x. So we seem to be on the right track. So sine 6x and cos 7 minus 5 by 2, which is 2 by 2 is 1, plus 2 times 9 plus 3 by 2 is 6 sine 6x, and cos 9 minus 3 by 2, which is 6 by 2, so 3x. And in the denominator, cos x plus cos y is 2 times cos x plus y by 2, cos x minus y by 2. So it becomes cos 7 plus 5 by 2 is 6, and 7 minus 5 by 2 is 1, and the second term becomes 9 plus 3 by 2 is 6, and 9 minus 3 by 2 is 3. Now sine 6x is common in both the terms in numerator, so we will take that common, 2 times sine 6x, and we are left with cos x plus cos 3x. In denominator, cos 6x is common, 2 times cos 6x is common, so we will take that as common, and we are left with cos x plus cos 3x. Now this 2 cancels 2, and this cos x plus 3x cancels cos x plus 3x, and we are left with sin 6x by cos 6x, which is equal to tan 6x, which is equal to our right hand side. Hence proved. So this way, if you see that, if you remember all these formula like sin x plus sin y, cos x plus cos y, cos 2 theta, sin 2 theta, tan 2 theta, and the expansions sin x plus y as in the first question. So if you remember these formula, and you can see where you can use which formula. So sometimes you may need to expand, sometimes you may need to combine terms. So these will automatically come with practice. You don't need too much practice. With some amount of practice, you should be able to figure out where you need to apply what formula. So thanks for watching. Keep learning, keep practicing. All the best.